Hello, welcome to Taxonomy Online Mathematics. Another beautiful day to take tutorial on the continuation of the topic matrix. So today we are taking the inverse of a 3 by 3 matrix. In the previous lesson, as in 2 by 2, we learned that the inverse is just the reciprocal of a number of a matrix, which is indicated by this. Also, to find the inverse of this, we learned that it is just the adjoint of the matrix over the determinants of the matrix, whereby this could be 1 over determinant of the matrix times the adjoint of the same matrix. So I explained that I will be explaining the adjoint, which in this case 2 by 2 is going to be the interchange of the position of AB. So if I have A, B, C, D, if I'm to change the position, it will just be D, A minus B minus C. So this is the adjoint we use to multiply that in 2 by 2 matrix. So in 3 by 3, we need to make use of all these three terms. 4 terms, I've already explained this. Now we need to learn what is a transpose. To transpose a matrix. For example, if I have matrix A to be equals to A, B, C, D, if I'm to transpose this, meaning the first row become what? The first column. The second row become the second column. So this is a transpose of the matrix A, written as A exponent T. So I've transposed this. If this is also given to me, A equals to 1, 2, if I'm to transpose this, don't forget in transposing this, we are going to take the whole of this to become a column. So 1, 2, 3, the row, 4, 5, 6, then 1, 7, 1. Don't forget, we were dealing with 3 by 3 matrix and we still get what? 3 by 3 matrix. So just to transpose, make sure the row become the first column, second row, second column, third row, third column. That is to transpose a matrix. And we are referring to 3 by 3. That's transpose. Now, to find a minor, we remember under determinant of 3 by 3. If you are to find a minor, you find a 2 by 2 inside the 3 by 3, meaning you delete an element. So if I take A, I'll cancel the row and the column of the 1. So I'll be left with this. This is the sub-matrix. So the determinant of this sub-matrix give me the entry of 1. That is giving me what? The minor of 1. If I take 2, it means I am cancelling this and all of this. So this and this, the determinant of this give me the minor of 2. So I think let's put it in. So let's see, we have this matrix A. We want to find what? The minor. So if I want to find minor of 2, I would like to go in a row form. So it means 2 is going to be, if I cover all this and this, I'll be left with this. So I'll find determinant of this. This time this is what? 36 minus the other diagonal, I have what? 35. So the minor of 2 is going to be 1. Clear? I'm going row by row. So as I've taken this, let me go for 3. So minor of 3 is going to be covering all the row of 3, covering all the column of 3. I'll be left with this and this. So what do I do? The product of leading diagonal, 24, other diagonal, 25, and that will give you minus what? 1. Let's go to this place. So minor of these 2 is just going to be cancelling all the column and all the row. I'm left with this leading diagonal 28. Other diagonal will be 30. So in this case, I'll be left with minus what? 2. So I am done with the row. Let me go back to 4. So minor of 4. Cover all this and the top. So I'll be left with what? 3, 6. 3, 6 is 18. Minus what? 7, 2. That will be 14. So I have 4 as my answer. Let's go to this. So we are covering all this and the middle. So what is left? 2, 2, 5, 6. So this will multiply this will give you what? 12. Then this will also multiply this will give you 10. So I have 2. I'm moving to this. So minor of 5 is going to be all this row is gone, the column is gone. I'm left with 2, 3, 4, 7. So 2, 7, 14. Then 2, 5, 3. That will be 15. Minus what? 1 as my answer. So I am done with this. So let's go to 5. Don't forget, all this is gone. The top is gone, so we are left with this. So leading diagonal, 15. Other diagonal, 12. You have what? 3 as your answer. So 7 is taking all of this and then down. So we are left with this. 2, 5, 10. 4, 2, 8 equals to 2. Then where do we go? The last one. So we are taking all of this. We are taking all of this. So we are left with this. 12 minus what? 12, right? 0. So the minor, which is indicated A exponent m, is going to be, what is a minor of 2? Minor of 2 is what? 1. Minor of 3 minus 1 of 2 minus 2, I'll come down to 4. 4 is what? 4. 6 is 2. 5 minus 1. The next 5, 3, 7 will be 2, and 6 will be what? 0. So this is the minor. So the minor of a matrix is just finding the determinant of the sub-matrix after an element is what? Covered or deleted. So it means you are going to find for each of them, and that is what we did per minor. Good. Then for the cofactor developed from the minor. When we assign pattern of sign, if you assign 3 by 3 determinant, we assign a pattern of sign plus minus plus minus plus minus plus minus what? Plus. If you assign this sign to this minor, it become what? Cofactor. It become what? Cofactor. So A exponent C, which is the cofactor. Cofactor is assigning pattern of sign to your matrix, to the minor. So this is plus, minus, plus. So plus will be 1, minus will be 1, plus minus plus. So I still have minus 2, plus minus. So minus 4, minus plus, minus. So I have 1. This is plus, minus, plus. So 3, plus, minus, and plus. We have what? 0. So let's call this the cofactor. Right? So we know what a transpose is. We know what a minor is. We know what a cofactor is. What about the adjoint? The adjoint is the transpose of a cofactor. So if I transpose this, per definition of this, if I transpose this, if you want to transpose this, it becomes, which is the adjoint, all of this become the column. So 1, 1, minus 2, the first row become the first column, the second row become the second column, and the third row become. So this is the transpose of the cofactor, and that is the same as the adjoint of what? A. So in order to find the inverse, we learned earlier on that is going to be 1 out of the determinant of A multiplying what? The adjoint of A. Meaning this matrix will be here. This particular matrix will be at this place. 1 divided by the determinant. We've already learned, we have not treated that here. We've already learned that in the previous lesson. So now let's find determinant. Then we can find the inverse of the given matrix. Alright. So now let's find the determinant of A. This is the same matrix we begin with, or we began with. We know I want to take the first row, so plus, minus, plus. So I will take 2, cover all this. So I'll be left with 6, 7, 5, 6. The bar. So minus 3. All these they go down, they go. So 4, 5, 5 what? 6. Then I'll be having plus. So plus 2. All this is going to be left with 4, 6, 5 what? 7. So let's go. This is 2 times leading diagonal 36, other diagonal 35, minus 3 leading 24, other 25, I guess. Then plus 2 leading diagonal will give us what? 28. Then the other will give you 30. Having 2 multiplying what? 1. Then minus 3 multiplying negative 1, as in this, plus 2 multiplying, I think that will also be negative 2. So right away, 2 plus 3 minus 4. So this will be 5. So we are going to have 1. 1, meaning our determinant of A is just what? 1. So if that is out of the way, our inverse, the inverse that we are looking for, we know it is 1 over determinant. So that's going to be 1 over 1, the determinant. Then the adjoint that we have, which is the transpose of cofactor. So that is going to be 1 minus 4, 3. So this is our inverse. Don't forget, 1 divided by 1 is 1. So in the next, after this, we'll be cleaning this out, maintaining this, meaning your inverse is the same as the adjugate or the adjoint. Better still, the transpose of the cofactor. Good. So these are the procedure that you have to follow. Minor, we need to find the minor. We need to find the cofactor, the transpose of the cofactor to become our adjoint. Then we need to find the determinant. How you want to start? You can start with the determinant first. Have your answer. Find the minor. Find the cofactor. Then the adjoint or adjugate. Then remember the formula. Then voila, you are there. Good. Thank you for watching. If you follow this, please don't forget to subscribe to the channel, like, share, and comment. Bye-bye.